Welcome back. Interfaces are supposed to be our best friends in code. They're these beautiful contracts that promise clean, decoupled designs. But let's be honest, sometimes they turned into these giant, bloated monsters that cause way more problems than they solve. Well, today, we're putting those interfaces on a much-needed diet with the fourth solid principle, the Interface Segregation Principle.
So let me ask you this, and I want you to be honest. Have you ever been forced to implement a method you didn't need? You throw a not implemented exception, or you just leave the body empty with a little comment like, I don't do this. If you're not in your head right now, you have absolutely felt the pain of a fat interface, and this explainer is definitely for you.
So here's our game plan. First, we're going to dig into the bloated interface problem. Then, we'll use a super simple analogy to make it all click. After that, we'll jump into some code to see a before and after. And finally, we'll talk about the real power of segregation and what you should take away from all this.
Okay, so when an interface just tries to do way too much, it starts to give off what we call design smells. These are basically just warning signs that something is structurally wrong with our code, making it brittle, fragile, and just a real headache to work with.
And two of the worst smells are rigidity and fragility. A rigid system is one where a tiny, seemingly simple change forces you to go on a wild goose chase, modifying a dozen other files. It's awful. But a fragile system? Oh, that's even worse. You make a change over here, and something completely unrelated breaks over there. And fat interfaces are a huge cause of this, because they create this tangled web of dependencies, forcing classes to care about methods they don't even use.
All right, before we dive into the code, let's make this whole principle really clear with a simple analogy that I think everyone can relate to.
Picture this. You walk into a restaurant at 8 a.m. You just want a cup of coffee, but the waiter hands you this massive 20-page menu. It's got breakfast, lunch, dinner, appetizers, the entire wine list, everything. It's overwhelming, right? And it's totally inefficient. You shouldn't be forced to sift through the dinner specials just to find the coffee.
And that's exactly what the Interface Segregation Principle says our code should do. The clients, and by that I mean the classes that use an interface, they shouldn't be forced to depend on methods they don't actually use. Just like a coffee drinker doesn't need the wine list, our code deserves small, specific, role-based interfaces.
All right, enough with the analogies. Let's get our hands dirty and put a bloated interface on that diet I was talking about.
So here we have a classic example of a fat interface. iMachine, it's a contract for any kind of office machine. And it basically says, hey, if you're a machine, you must be able to print, scan, and fax. At first glance, you might think, okay, that seems reasonable, but the trouble starts when you actually try to use it.
And boom, here's the problem. We create a simple printer class. Now, it can print just fine, no problem there, but it can't scan and it can't fax. But because it has to follow the rules of the iMachine interface, it's forced to provide implementations for scan and fax. This leads to those empty methods we talked about, or even worse, methods that throw an exception. It's just a messy, confusing design. The client is being polluted with methods it has no business knowing about.
And this brings us right to the formal definition from Robert C. Martin himself. Clients should not be forced to depend on interfaces that they do not use. Our simple printer is a client, and it's being forced to depend on scan and fax, which it does not use. This is the exact problem ISP is designed to solve.
So what's the fix? Well, it's actually pretty elegant. We segregate the interface. We take that one big fat iMachine interface and we break it down into smaller, highly cohesive, role-based interfaces. Now we have an iPrinter, an iScanner, and an iFaxer. Each one does one thing and does it well. And just look at the result. It is so much cleaner. Our simple printer now only implements the iPrinter interface, the one and only thing it actually cares about. And what if we have a more complex machine, like a multifunction machine? No problem. It can just implement all three interfaces. We get total flexibility, and our clients are finally clean and focused.
Now, this isn't just some academic exercise to make our code look pretty. Applying this principle has real, practical benefits for the long-term health of your entire code base.
When you create these smaller, focused interfaces, you automatically get higher cohesion. Each interface is dedicated to a single clear role. That leads to much better decoupling, since your classes only depend on the exact methods they need. And what does that give you? Well, it makes your code way easier to understand, way simpler to test in isolation, and a whole lot easier to refactor down the road. Your system just becomes more adaptable and resilient to change.
The real danger here is that when you force a class to depend on things it doesn't use, you create all this unnecessary coupling. And, as the source material puts it so well,
This leads to fragile designs that break in unexpected ways when changed. ISP is how we cut those dangerous, unnecessary connections.
So let's wrap this all up. Let's boil it down to the one key idea you should take with you to your very next coding session.
It really is this simple. Prefer lots of small, client-specific interfaces over one big, general-purpose one. Resist that temptation to create a God interface that tries to do everything for everyone. Think of it as the single responsibility principle, but for interfaces. Focus on the job of the client and give it exactly what it needs and nothing more.
Now, I really want to hear your war stories. What is the biggest, most bloated, most monstrous interface you've ever had to work with? How many methods did it have? Drop a comment below. Let's compare notes.
We are so close to the finish line of our solid series. In our final explainer, we are going to cover the big one, the dependency inversion principle. This is the D in solid, and trust me, it's the principle that ties everything together. It's what makes high-level concepts like dependency injection and clean architecture even possible. You are not going to want to miss this one. I'll see you in the final explainer.